In a silent vastness beyond Pluto, something is moving. A tiny speck of light is heading inward from the interstellar dark. It is clearly not from around here. Astronomers have just realized that we have a visitor from another star system.
In mid-2025, a telescope in Chile detected this mysterious object, the third ever discovered since the mysterious Oumuamua stunned the world in 2017, moving along at an unusual trajectory. At first, it was just a faint blip in the Asteroid Terrestrial Impact Last Alert System, or ATLAS for short, which scans the sky for anything out of the ordinary. The discovery caused a wave of excitement and confusion. Was it a comet? An asteroid? And why did its trajectory look so strange? The object was first spotted on July 1, 2025 by the Atlas Survey Telescope in Rio Hurtado, Chile, initially labeled with the cryptic designation A11PL3Z. It quickly drew attention, as its orbit didn't match any known within our solar system. The next day, the International Astronomical Union confirmed what many had already begun to suspect. This was an interstellar object, only the third ever found. They officially named it 3I/Atlas, where I stands for interstellar. Picture this, a chunk of rock and ice having traveled from another star, now passing through our cosmic neighborhood. For astronomers, it was a eureka moment. For everyone else, it raised an uneasy question. Should we be worried about this alien comet? The reassuring answer is no, there's nothing to fear. Scientists determined from the beginning that 3I Atlas poses no direct threat to Earth. Its path will keep it at a safe distance. At its closest, it'll be more than 150 million miles from us, about 1.6 astronomical units, or 1.6 times the distance from Earth to the Sun. In fact, this visitor won't even come closer than the orbit of Mars, so there's no risk of collision, only a rare chance to gain knowledge. Larry Deneau, one of the scientists behind the ATLAS project, admitted that we don't know very much about this object. For experts, saying we don't know is both humbling and thrilling, because it means something truly new has been found. Here's what we do know. 3I Atlas is up to 12 miles wide, making it a massive cosmic iceberg. When first spotted, it was about 4.5 astronomical units from the Sun, 4.5 times farther than Earth, and now it's racing at an incredible speed of about 40 miles per second. That's over 140,000 miles per hour relative to the Sun. No known comet from our system travels this fast on its own, so it's clear that this thing was ejected from far away. The Minor Planet Center's official circular made it clear we're dealing with something special. They reported tentative cometary activity with a marginal coma and a short 3 arc-second tail. In other words, 3I Atlas isn't just a dead rock. It's already showing signs of life, like a comet waking up from a solar heat. There's a coma, a fuzzy halo of gas and dust surrounding the comet's core, and even a tiny dust tail. It's beginning to sublimate, meaning its frozen gases are warming up and turning straight into vapor, forming a glowing coma and a trail of particles behind it. All of these observations took place when 3I Atlas was still very distant and faint, around 18th magnitude, far too dim to see without a large telescope. Yet the fact that we even noticed it shows how far astronomy has come. It took global cooperation after Atlas flagged the object Telescopes in Hawaii and Australia joined in to track it and map its path. Amateur astronomers dug through old images and found pre-discovery photos of the object hidden in data from mid-June 2025. These early observations helped refine its trajectory and confirm its interstellar origin. So by July 2025, the verdict was in. An interstellar comet was approaching, only the third ever seen by human eyes. Naturally, the next question was how this cosmic wanderer compares to the others. To understand how unusual 3I Atlas is, let's recall its two predecessors. The first was discovered in late 2017 and given the Hawaiian name Oumuamua, meaning scout or messenger from afar. The second, discovered in 2019, was 2I Borisov, named after the amateur astronomer who found it. The two were very different from each other, and 3I Atlas adds a new twist to the story. Oumuamua was a true mystery. It was a small, about 100 yards long, oddly shaped cigar-like object, which had no visible coma or tail like a typical comet. As it moved away, it even showed slight, non-gravitational acceleration, veering off the path predicted by gravity alone. This may have been due to gas outflow or something even more exotic. This strange behavior led to wild speculation, though most scientists lean towards natural explanations, perhaps a fragment from an icy world like Pluto. Either way, Oumuamua left us with more questions than answers. 2I Borisov, by contrast, was more familiar. When Borisov arrived in 2019, it looked and behaved like a regular comet from our solar system. It had a bright gas coma and a tail, and its composition, analyzed using the spectroscopy method, was similar to known comets with water vapor and carbon-based molecules. If not for its hyperbolic unbound orbit, one might have thought Borisov was homegrown. Now we have 3I Atlas, and the main question is, which of the two does this new guest resemble? Early signs suggest Atlas is more like Borisov than Oumuamua. It's faint and fast-moving, but has a typical fuzzy coma indicating the presence and evaporation of ice. This suggests it's most likely an icy comet-like body rather than a dense rock. It's important to note that it hasn't shown any obviously strange behavior so far. In short, no signs of an alien spacecraft at this time, just a very interesting comet from another star. There is, however, something quite distinct about this object: its size. The new object appears to be larger than both Oumuamua and Borisov combined. Based on its brightness at the time of discovery, astronomers estimate that it could be about 9 to 12 miles across, significantly bigger than Borisov, which was around 0.6 to 1.2 miles in width, and much larger than the tiny Oumuamua. If this estimate holds true, Atlas could have much more mass, potentially offering a richer supply of material to observe as it outgasses. Borisov arrived from a completely different part of the sky in the direction of Cassiopeia. Another contrast lies in the tilt of its trajectory and direction of travel. Oumuamua came from the plane of the solar system, roughly from the direction of the star Vega. Our newcomer seems to be coming from the constellation Sagittarius, roughly from the direction of the galactic center region. In galactic terms, Marshall Eubanks, the physicist tracking the object, notes that Atlas likely originated in the thin disk of the Milky Way galaxy. The thin disk is a flattened plane in which most stars, including the Sun, orbit the galactic center. This suggests the object may have formed around a star somewhere inside the vast swirl of the Milky Way's disk. Of course, we don't know exactly where that star may have been. To determine that, we'd need to trace back the comet's path and account for millions of years of galactic drift, which is practically impossible with current data. but the fact that it likely came from the inner galaxy already hints that it might be made from material similar to what we see in local comets. It's important to mention that all these interstellar visitors, no matter how different they are from one another, share one thing in common: they are not bound to the sun. Each of them travels on an open-ended hyperbolic orbit, meaning they arrive, swing once around the sun, and then head back to interstellar space, never to return. It was precisely this hyperbolic trajectory that told us Atlas wasn't local. Calculations immediately showed an orbital eccentricity of about 6, far greater than the value of 1 that defines the limit for bound orbits. This indicates the object is not tied to our star and came from beyond the solar system. Still, one can't help but wonder what story did this object live through before arriving here. Perhaps it was once a comet orbiting a distant star, peacefully circling its sun like Halley's Comet orbits ours. Maybe a close encounter with a giant planet in that alien system knocked it off course, flinging it into interstellar emptiness. For centuries, it drifted through the darkness between stars until chance brought it into the path of our sun. We may never know the full story, but as the third interstellar object draws near, we're gathering every clue we can about its nature. Now, halfway through 2025, 3I Atlas is approaching, and astronomers around the world are watching it eagerly. Let's examine its orbit and current state in more detail. What do we know about where it's going and what it is doing on its journey? The orbit of Atlas, as we've said, is highly hyperbolic, which means it's a one-time visitor. It arrived from interstellar space, and after swinging past the sun, it will return to interstellar space. Specifically, calculations show it will reach its closest point to the sun, the perihelion, around the end of October 2025. For Atlas, the perihelion distance is about 1.4 astronomical units, or roughly 130 million miles from the sun. Practically speaking, that's just inside the orbit of Mars. It's also worth noting that on its way, the object will pass relatively close to Mars. In October, it's expected to come within 0.4 astronomical units of Mars, or about 37 million miles from the red planet. While not extremely close, that's still near enough for spacecraft orbiting Mars to possibly observe it. For example, NASA's Mars Reconnaissance Orbiter might capture an image when 3I Atlas goes past. Scientists are currently studying whether cameras based on or near Mars could capture the event. As we've noted before, this comet is moving extremely fast. Even far from the sun, its speed relative to the sun is about 37 miles per second, and it's accelerating as it falls inward, pulled by the gravity of our star. By the time it passes through perihelion, it should be moving at over 150,000 miles per hour. And for reference, that's about twice the speed at which the Earth travels along its orbit. After swinging around our star, Atlas will have picked up enough speed to completely escape its gravity. In fact, by April 2026, when it is back in orbit, its relative speed to Earth could be around 55 miles per second, which would make it the record-setting natural object. Essentially, we're watching one of the fastest objects ever observed in our solar system. The third interstellar object is already classified as an active comet. The early reports of a marginal coma and short tail have since been confirmed. As the comet moves through the outer solar system, the heat from the sun begins to evaporate the ice on its surface. This process, or sublimation, releases gas and dust, forming a hazy coma around the core and a growing tail trailing behind it, pushed by the solar wind and sunlight. As of mid-2025, the coma remains weak. The comet's visible brightness is around 18th magnitude, far too dim to see with the naked eye. However, large amateur telescopes are able to capture it. Observers using sensitive CCD cameras and long exposures have started capturing it as a faint smudge moving across the star field. With each passing week, as more ice evaporates and it draws closer, the comet should grow brighter. It's predicted that by August or September 2025, it may reach 15th or 16th magnitude, perhaps even slightly brighter. That's still too faint for the naked eye. For reference, the faintest stars visible without a telescope on a very dark night are around 6th magnitude. However, a 15th or 16th magnitude comet will be accessible to many amateur astronomers with telescopes and high-quality cameras. Nick James of the British Astronomical Association noted that Atlas should be observable with amateur equipment for the next year or so. Still, we should temper our expectations. Comets are famously unpredictable. Astronomers expect that since 3I Atlas formed around another star, it may not follow the usual rules when it comes to brightness. It could flare more dramatically than expected or fizzle out entirely if its surface crust limits gas release. So, what is the third interstellar object really made of? Well, that's a fundamental question. If we can obtain spectra of its coma, splitting its light into a rainbow to identify chemical fingerprints, we'll be able to compare its composition to that of comets from our own system. When 2I Borisov was being studied, astronomers found familiar gases like cyanide, diatomic carbon, and water vapor, as well as large amounts of carbon monoxide, suggesting it may have come from a colder stellar system. As for 3I Atlas, early signs suggest it is not rock, but mostly ice, as indicated by the hazy coma. As Atlas approaches the Sun, we expect it to heat up and sublimate more intensely. Hopefully this will allow us to detect the presence of specific gases. Telescopes may look for signs of water, carbon-based molecules, or something unusual such as oxygen and organic compounds. It's like a lab sample from another star's pantry. Whatever we find or don't find should tell us how similar this comet is to those born around the Sun. Could it contain the same ingredients? If Atlas turns out to be chemically similar to our local comets, it would suggest the building blocks of planets and possibly life itself are shared across the galaxy. If it's different, that will be intriguing in its own way. It may have formed in an environment with a very different chemical makeup. So, what's all the fuss about? Why are scientists so excited about a comet that won't even be bright enough for most people to see? The importance of 3I Atlas lies in the fact that it is a physical sample from another star system passing through right on our doorstep. Think of it as a piece of debris from an alien world coming to visit completely free of charge. Throughout human history, we've only ever studied samples from our own solar system, moon rocks, Martian meteorites, comet dust, and asteroid samples from space missions. But interstellar objects like this give us a chance to study the chemistry and conditions around other stars without the need to send a spacecraft. A journey that with our current technology would take tens of thousands of years. Atlas is a messenger from afar, potentially carrying vital information about the building blocks of planets or even life in distant corners of the universe. These objects may contain clues in their makeup, perhaps different isotope ratios, rare molecules, or other features that reveal how and where they were formed. There's also the simple matter of curiosity and basic science. Each interstellar object is one of a kind. With only 2 previous cases, every new visitor from beyond the stars can dramatically improve our understanding. Is the third interstellar object an outlier or part of a pattern? If its composition turns out to be very similar to Borisov's, we might start suspecting that many star systems produce comets like ours. If it's drastically different, that could point to a more exotic origin. And with 3 samples, we can start estimating how common these interstellar wanderers really are. Some scientists believe that thousands of such objects might be passing through the solar system at any given time, most of them simply too faint to detect. As our telescopes improve, we may begin spotting them on a regular basis. In essence, we are entering a new age of discovery. The Vera C. Rubin Observatory in Chile has already started operations this year. Its legacy survey of space and time will scan the sky night after night with tremendous sensitivity. Experts predict that Rubin could discover several new interstellar objects over the next decade. That means Atlas might just be the first of many visitors from the stars we'll meet in the near future. Studying 3I Atlas also has a practical application preparing for the future. Agencies like NASA and ESA are interested in these objects not only for pure science, but also because of the potential challenge they pose. These objects move fast and are often detected without warning. What if one day an interstellar object is on a collision course with Earth? We'd want to understand its behavior and composition to determine if it's a threat or an opportunity. What's more, missions are now being designed to visit or intercept such objects. One example is ESA's Comet Interceptor, scheduled to launch in 2029. It's a spacecraft that will wait in space for a suitable target, possibly a pristine Oort cloud comet, or who knows, maybe even another interstellar visitor, and then race to meet it. The idea is to be on standby so that we don't have to scramble and start from scratch in case an unexpected visitor makes an appearance. If we already had a probe right now, just imagine what we could learn by flying past this third interstellar object and directly sampling its dust and gases. Future technologies might allow us to do exactly that. As for 3I Atlas itself, there's no plan for a spacecraft visit as of today. This object was discovered just a few months before its closest approach, far too late for an intercept. It'll be gone just as quickly as it came. But the lessons we learn now will be invaluable for developing future missions. Maybe the next interstellar visitor will be spotted years before perihelion, giving us time to prepare a rendezvous. The scientists point out, even our fastest rockets would take tens of thousands of years to reach the nearest stars. An object like this brings a piece to one of us. That's a chance we can't afford to waste. So, should we panic about 3I Atlas? No. On the contrary, we should marvel at it. It's a reminder that space isn't a closed system. Matter and perhaps even the seeds of life can travel from star to star. Right now, astronomers around the world are turning their telescopes toward the third interstellar object. Both professional observatories and experienced amateurs are taking images on clear nights. They're measuring its brightness, watching its tail grow, and refining its orbit with each new observation. Until September 2025, the comet will be well placed for observation from Earth's night side. After that, around October, it will appear too close to the Sun from our point of view, making it temporarily unobservable due to solar glare. At the end of October, when it reaches perihelion, its closest point to the Sun, it will lie almost in line with the Sun from Earth's perspective, effectively hidden in daylight. But by early December 2025, as 3I Atlas begins its journey out of the system, it will reappear in our sky. We'll have one more brief chance to observe it as it heads out before it vanishes forever into the darkness of space. Scientists know it might be decades or more before we get another opportunity like this. Visitor from another star system will soon be gone, but the things we learn will stay with us forever, bringing us one step closer to understanding our place in a universe full of wanderers.